So let's solve this initial value problem. We will begin by rewriting the given differential equation as, so we have dy over dx, so this will be equals to x times e raised to the power of y over x plus y whole divided by x. The expression on the right hand side can be further simplified to e raised to the power of y over x plus y over x. Now, this is a special type of differential equation. This is referred to as the homogeneous differential equation. The reason behind this is, if we consider this particular expression, and let's suppose that this is denoted by the function f. Now what we'll do, in place of x and y, we'll replace it with lambda x and lambda y respectively. So this is going to give us e raised to the power of, so in place of y, we have lambda y divided by lambda x plus lambda y divided by lambda x, and that gives back us the original function f of x comma y. Now what we do, we can also rewrite it as a factor multiplied to it, which will be lambda raised to the power of 0. So when we have a criterion of this type, we can say that our function is homogeneous in nature with a degree of 0. So since this is a homogeneous function, so our differential equation is also a homogeneous differential equation. Now how to solve this type of differential equation? All we have to do is, we suppose that y is equals to v times x. Now we differentiate both sides with respect to x, so that will give us dy over dx equals to v plus x times dv over dx. So we'll use this value and rewrite a differential equation as, so we have v plus x times dv over dx. So this will be equals to e raised to the power of, so we have y over x, so that will be v plus y over x. So y over x, that will be v. So we can see that the v and v cancels out, and now we are left with x times dv over dx. So let's rewrite this in a variable separable form. So we have e raised to the power of negative v dv, that will be equals to dx over x. So that means we can now integrate both sides. Integration of the exponential function is the function itself, but we have to multiply with a negative, equals to integration of dx over x. So that's going to be natural log of x plus the constant of integration c. Now we'll substitute v with negative y over x. So this is equals to natural log of x plus c. All that we have to do now is to determine the value of c. We are provided with the initial conditions, that is y of 1 equals to 1, which simply means that when x approaches the value of 1, then y is going to approach the value 1. So we'll substitute this value here. So we have negative e raised to the power of negative 1 over 1. So that will be negative 1, which will be equals to natural log of 1 plus c. Log of 1, this is always 0. So that means our c value is negative 1 over e. So we'll substitute this value into this equation. So we have negative e raised to the power of negative y over x equals to log of x minus 1 over e. Or we can write it in a cleaner way. So we have 1 over e minus 1 over e raised to the power of y over x. So this will be equals to natural log of x. So this is the required solution to a given differential equation.